For this lesson, we're going to be talking about solving quadratic equations, specifically solving multiple different kinds of quadratic equations. We're going to focus on four techniques. First, solving quadratic equations by factoring, then by using the square root property, then we will look at solving quadratic equations by completing the square, and then lastly, we will work on solving quadratic equations by throwing them into the quadratic formula. So let's first start by talking about factoring quadratic equations. Now, definitely make sure that you have an overview over all the different factoring techniques before jumping into solving quadratic equations by factoring. So the first thing that we want to do when we're solving a quadratic equation by factoring is we want to make sure that it is in proper quadratic form. Now, when I say that, proper quadratic form is this right over here. Ax squared plus bx is plus bx plus c is equal to 0. Essentially, make sure everything is over to one side of your equation and it is set equal to 0. So the first thing I'm going to do here is I'm going to take this x, and since it says minus x, we are going to add that x to the other side. That way it does cancel out from the right-hand side. And actually, in the same line, I'm going to go ahead and move that 1 over. It is a positive 1 on the right-hand side, so we are going to have to subtract that 1 to the left-hand side. So when we do that, we are dropping down the 2x squared that was already there, and then we added an x and subtracted a 1, so that everything is on the left side of our equation and it is set equal to 0. So now we are ready to factor this. And what we're doing here is we're factoring a trinomial that has a leading coefficient that is not a 1. There's multiple names for different techniques on how to do this. There's many, many different factoring techniques. I like to use what is called no-fuss factoring. The way that no-fuss factoring works is, so I'm going to go ahead and set up my two sets of parentheses that we're going to factor into, okay? And what you're going to do is you're going to take that ax, that first term excluding the exponent. In our example here, that is a 2x. And just repeat that twice. Put it in the first spots in your parentheses. 2x and 2x. The next thing that you're going to do is you're going to multiply a times c. The first number times the last number, ignoring any signs. All right, so that gives us 2 times 1, which is just a 2. And typically, you would just make your list of all the different numbers that multiply to get to 2. Now, the only thing that multiplies to get to 2 is a 1 times a 2. So we have to use those combinations of numbers. Typically, you're looking for what combination of numbers multiply to get that, but add or subtract to get your middle term. The next thing that we're going to focus on in our factoring is our signs. If your last term over here is negative, what that tells us is we're going to have different signs inside our parentheses. One of these is going to have a plus, one is going to have a minus. The way that you know which one goes where, always look at your middle sign. Our middle sign is plus, and pay attention to this rule. Whatever sign the middle term has, the bigger number must have it. Our middle term is positive, which means that plus must go with this 2 over here, since 2 is bigger than 1. Okay, so the middle sign always goes with the bigger number, and since we know we have to have different signs, we already use the plus, so we have to use the minus over here. The last step in no-fuss factoring is one or both of your factors are going to be able to be reduced. So take a look at the numbers inside your parentheses. For our first set of factors here, for our first factor, we have a 1 and a 2. There's nothing we can do with that one, so we're just going to drop that down. Drop down 2x minus 1. But when we look at our second factor, we have a 2 and a 2, which definitely means that we can reduce this. So literally think like reducing fractions. They both have a 2, which means we have a 2 in common. And what we're going to do is we're just going to divide each one of these by a 2, right? You reduce it out, just like you're simplifying a fraction. And when we do that, we are left with x plus 1. Okay? We have factored our problem then. The factoring is done. So what's left of this is we are going to use what is called the zero factor property. The zero factor property tells us that once we have this in factored form, we can split these up into two different equations, right? So what we're going to do is we're going to take the 2x minus 1, and split that up into its own equation set equal to 0. And then we're going to take the x plus 1, also set that equal to 0 into its own equation. And we just need to solve both of these to get our solution. When we solve the first equation, we are going to add 1 to both sides. And I am running out of room here, but we're going to add 1 to both sides and divide by that 2. And we are left that x is equal to a positive 1/2. And then for the equation on the right, all we have to do is subtract a 1 on each side. And we get that x is equal to a negative 1. So we get a positive 1/2 and a negative 1 as our solutions here. For this next example, we're going to be using the technique of solving a quadratic equation by taking the square root property. So sometimes we don't need to go through and do the entire full factoring technique. So for this one here, for this technique here, what we're going to do is we're going to get our squared term isolated. So our squared term is the x squared that's sitting right over here. So what we want to do is we want to focus on getting rid of everything else and move it to the right-hand side. So the first thing we're going to do is move away that 45. Since it's a plus 45, we are going to subtract 45 on each side. When we do that, we are left with 5x squared is equal to a negative 45. We're next going to get rid of the 5 in front. Remember that 5 is getting multiplied to the x squared, so we do the opposite and divide it away. So we're going to divide both sides by 5, leaving us with x squared is equal to a negative 9. Now after this, the only thing left to do in order to solve for x, right, we have that x squared. So we need to undo the square. The opposite of a square is taking the square root. So what we're going to do is we're going to take the square root of each side, and that will solve our problem for us. On the left-hand side, the square root and the square will cancel, leaving us with an x. And on the right-hand side, okay, so when we're taking a square root of something, especially something with a negative, you got to keep in mind that the square root of a negative 1 is equal to I. So when I take square roots, I like to kind of just split it up based on what I have. Right now we have the square root of negative 9. And I like to split this up into the square root of 1 times the square root of 9. We are able to do that. Now we're able to take the square root of 9. The square root of 9 is actually a 3. Keep in mind it is a plus or minus 3, since 3 times 3 is 9 and negative 3 times negative 3 is 9. Also keep in mind that the square root of negative 1, I'm sorry I forgot that negative symbol on there. Keep in mind that the square root of negative 1 is equal to an I. So really what we have here, the square root of negative 9 is equal to plus or minus 3i. And those two, a positive 3i, negative 3i, are our solutions for this problem. For our next problem, we're going to be focusing on solving a quadratic equation by completing the square. So taking a look at the example we have here, the first step in solving a quadratic equation by completing the square is to divide the entire equation by that leading coefficient. So if your quadratic equation has a number in front that's not a 1 like we do here, ours is a 9, we need to get rid of that 9, and we do so by dividing everything by 9, the entire equation. We want that leading coefficient to be a 1. So when we do that, 9 over 9 cancels, leaving us with x squared, minus 6 over 9 does not divide out all the way, and we do not want the decimals, but we are going to reduce this by dividing out a 3 there to get 2/3 x, minus 4 over 9 does not simplify, so we just drop that down, and 0 over 9 is equal to 0. Okay, so that's the first step. Now, step 2 of completing the square tells us to take our constant, our c, right, our last number over here, the minus 4/9, move that over to the other side of the equation. So we are going to add 4/9 to the right-hand side of the equation. You always want to get rid of your constant, the standalone number. You want to get rid of it and always move it to the opposite side of the equation. So you just have your x squared and your x. All right, so we'll have x squared minus 2/3 x. We're going to leave a space, and that is equal to 4/9. Now, the reason why we move the 4/9 over to the other side is because, when it comes to solving quadratic equations by factoring is the nicest, quickest, tends to be the easiest technique to solve a quadratic equation. But we're not always able to factor. Just like this problem right here, that 4/9 is not going to be a nice number to try and factor this problem as it is from the beginning. So what we do is we move over the constant, and our next step here, step 3, we are going to add something to both sides of our equation. Now the thing that we're going to add is 1/2 times b squared. So this is a little mini formula that comes with this technique. You do need to know this, and you do use this anytime you're going to be completing the square. Now remember that b is just the coefficient of x to the first power. So when we calculate this, this is going to be 1/2 times b. Now our b, our middle term, is a 2/3. You don't have to pull the sign with it because we're going to square it here in a little bit and all signs are going to disappear. So all we need to grab is the 2/3, right? It's the coefficient of x. When we multiply this on the inside here, we are left with 2/6 as our fraction when we multiply that, right? 1 times 2 is 2, 2 times 3 is 6. We do need to reduce this and divide each side by 2, which is going to give us 1/3, actually, when we simplify that fraction. And we still need to square this here. If we take 1/3 times 1/3, that does give us 1/9. Okay, so 1/9, by using this little formula right over here, 1/9 is the magic number that we need, that we are going to add to both sides of our equation. Right, to keep your equation balanced, you need to add it to the left and to the right side. Now, what's going to happen here is completing the square process, we should be able to now factor the left-hand side of our problem nice and pretty. All right, so the way that this is going to factor, that first term, x squared, we know that x times x gives us x squared. Now to figure out what our numbers are here, so the beautiful thing about completing the square, so even when you're messing with fractions like this, go back up to your 1/2 times b squared. And we got 1/9 as our final answer when we did that. Now we don't, for this next step here to figure out the number that's going to go inside our parentheses when we factor, if we just go one step above, right before we multiplied, the number inside the parentheses before we square, that was a 1/3. Actually, that 1/3 just happens to be the number that we need to go inside these parentheses. It will happen that way every time. Use the 1/2 b squared to know what you're adding to each side of the equation, but just go one step before that. The number before you square is going to give you the numbers you need to factor. And the only thing left to factor here is our signs. Now, the whole point of completing the square is these factors are supposed to be exactly the same. Notice they both each have an x. They both each have a 1/3. They also both need to have the same sign. So taking a look at the combination of signs from our problem right before this, that plus in front of the 1/9 means that we will have same signs. Looking at the middle term will always tell you which. Our middle term is negative, so we're going to throw in some minuses inside here. And to shorthand this problem here, since we do have x minus 1/3 times x minus 1/3, we are just going to rewrite that as x minus 1/3 squared. And that is our left-hand side. Our right-hand side, remember we moved over that 4/9 earlier, and we had to add that 1/9 to each side. So 4/9 plus 1/9 gives us 5/9. Once we are done with our factoring, the rest of this problem is actually using the previous technique, solving by using the square root property. Notice on the left side, we have our squared term here. We need to get rid of that square, and we do so by taking the square root. On the left, square root and square cancel, and we drop down our x minus 1/3. And on the right-hand side, let's drop down a plus or minus in front of that. Remember, we need to do that any single time we're working with a radical. Otherwise, what I'm going to do here, instead of saying the square root of 5/9, I'm going to say the square root of 5 over the square root of 9. The reason why I do this is because I can clean up this radical over here on the right-hand side, dropping down the plus or minus. We cannot take the square root of 5. 5 is a prime number. There are no perfect squares that are going to help us break down a square root of 5. It cannot be simplified. It cannot be broken down. But we can definitely take the square root of 9 because the square root of 9 is a 3. Okay, so this is actually x minus 1/3 is equal to plus or minus square root of 5 over 3. We almost have it solved for x, so we need to just add that 1/3 to both sides here to give us that x is equal to. So let's take a look at what we're working with here. We have plus or minus the square root of 5 over 3 plus 1/3, right, is where we're currently at. Sometimes this is okay to leave your answer like this, but a lot of times they do want these two fractions combined. Do notice that they do have common denominators, so we can already just combine them together. We had a plus or minus square root of 5 plus the 1 from the other fraction all over 3. All right, well, otherwise, that is the solution for this particular problem. For this last problem, we're going to focus on solving a quadratic equation by using the quadratic formula. So I have the quadratic formula written on the right-hand side over here, right? X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now we got to keep in mind that the a's, b's, and c's that we see in the quadratic formula come straight from the standard form of a quadratic equation. The a is always the coefficient of x squared, b is always the coefficient of x to the first, and c is always your constant. So anytime we start a problem like we're going to here, I always like to start by just designating exactly what a, b, and c are, because the signs do go along with the numbers there. That means for this example that we're looking at, a is a 3, since that's in front of x squared, b is a negative 2, and c is a positive 4. So we're going to just throw this into the formula. The negative is part of the formula, and that says negative b, which is a negative 2, plus or minus the square root of b squared, so negative 2 squared, minus 4 times a, which is a 3, times c, which is a 4. And this would be all over 2 times a, which is a 3. The rest of it is just simplifying, so let's take that one step at a time. At the beginning here, negative, negative 2, that's a double negative rule. 2 negatives do cancel out to a positive, so that is a positive 2. Drop down the plus or minus sign as we focus on simplifying underneath that radical. The first thing we have under that radical is this negative 2 squared, which tells us negative 2 times negative 2, which is a positive 4. Then the rest of it, minus 4 times 3 is 12, and 12 times 4 is 48. All over 2 times 3, which is 6. All right, so in the next line, all we're going to do is subtract what's under the radical. 4 minus 48 gives us a negative 44 over 6. Now what I'm going to do is I'm going to pull out our radicals so that we can work on simplifying this, and then we'll throw it back in the problem. Now, the way that I like to work with my radicals is anytime you have a negative under the radical, remember that that negative does become an I. We do have the rule that the square root of a negative 1 is equal to I. So what I like to do is break up the number like this. Instead of square root of negative 44, I know that this is the same thing as negative 1 times times 44, right? Since negative 1 times 44 is, negative 44. But I'm going to break up that 44 even further. So I'm going to drop down the square root of negative 1. And what we want to do is we want to simplify the square root of 44, or we want to break it up into a multiplication using perfect squares. Perfect squares are your numbers like 4, 9, 16, 25, 36, 49, right? 3 times 3, 4 times 4, 5 times 5, so on like that. That is how you want to reduce with radicals. And the perfect square that's going to work here for us with the square root of 44, well, 44 happens to be 4 times 11. And we break it up this way so that we can reduce the radical as much as possible since most books prefer radicals to be simplified in radical form, not in decimal form like a lot of calculators will give us. So let's take the square root of what we can. The square root of 4 is 2. All right, that takes care of that one. The square root of -1 is I. Square root of 11 cannot be simplified, so that just drops down. So that means the square root of -44 is a plus or minus. Remember, plus or minus always goes in front of radicals. The 2i square roots of 11. Let's throw that back in our problem. To get 2 plus or minus 2i square roots of 11 over 6. The last thing to do here is to reduce our fraction. We do have 3 terms in our fraction. 1, 2, 3. All 3 terms have an even number in it because we have 2, 2, and 6. So what I'm going to do is I'm going to reduce this fraction by a factor of 2. I'm essentially just going to divide everything by 2, just like that. Divide by 2, divide by 2, divide by 2. Here in front, 2 divided by 2 is 1. Drop down the plus or minus. Then we also have another 2 divided by 2, which is 1. And we don't write 1i, we just write the I. The 1 kind of just disappears off. So that will be I square roots of 11 over 6 divided by 2 is 3. And that would be our final answer here for this problem.